All right, next we're going to be working with number 4. This is a particle problem. I noticed that we had a lot of problems with particle problems, but hopefully at this point we'll be doing a little bit better. This question is a little tedious, but honestly not really terrible. So it says a particle moves along the x-axis with the position given by this. Find the time which the particle is furthest left. So basically what you want to do is you're trying to see, okay, where's my particle moving? Over here. Excuse me, sorry. I'm not sure why. My nose is just driving me crazy, so I'm going to be scratching it constantly. But basically, what we're going to be doing here is I'm trying to figure out the movement. So this is an SVA type question, right? Speed or position, velocity, acceleration. So first here it says, where is it furthest to the left? So basically, I'm going to look at the movement. If my velocity is positive, I'm moving to the right. If my velocity is negative, I'm moving to the left. So I'm going to look at my critical values. Then I'm going to look which critical values am I going left, and then I stop going left and I turn around. So again, I'm going to be kind of setting up my sign chart here. Anytime positive, negative, that means I was moving right and I turned around, started moving left. This here is a possibility because it's saying I was moving left, I stopped, and I started moving right. So again, that's what we're looking for. We're looking for critical values where there's turnaround points. So first thing we're going to have to do is find x prime of t. That's an x. So x prime of t is going to be equal to negative e to the negative t sine t. So we're going to use product rule here, plus e to the negative t cosine of t. And then my goal here is to set this equal to 0. So I'm going to factor out that e to the negative t. And then this is going to be left with cosine t minus sine t. And basically what we're saying here is this is going to be equal to 0, where this is equal to 0, or this is equal to 0. And the only place where the second portion is equal to 0 is at pi over 4. And you want to make sure that they have the same symbols. So if you remember, your pi over 4 is ASTC. So here it'll work, and here it'll work. Because in sine, this is going to be negative, and this is going to be positive. So it's going to be negative square root 2 over 2 plus square root 2 over 2, but that since the minus is there, it's going to be minus square root 2 over 2, so it's not going to cancel out. But again, we want it to be equal to 0. We just got to do a little bit of big braining over here. But my goal is where these two are equal to each other, and we know that's wherever sine is equal to cosine, which is at pi over 4, and that's only going to happen in quadrants 1 and quadrants 3, where they're both positive or both negative. So that means it's going to be pi over 4 and 5 pi over 4. However, we do have to consider the fact that it could be the endpoints as well. So we're going to go 2 pi and negative or and 0. So again, basically what we're doing here is we're looking at this as an SVA problem, but it's also going to be a local min, local max kind of problem as well. And here we're trying to find our absolute minimum. Much like our water problem, we're saying maybe I rose, maybe I started falling again, maybe I started up here, and even though I eventually rose later, I never came back from that initial dive. Same thing over here. That's why you check your endpoints. So critical values and endpoints. So then from over here, we're just going to plug it in, but not to this. We're going to plug it into my original position equation. So we're going to have e to the negative t sine of t. So if I plug it in here, I get 0. 2 pi is obviously 0. Pi over 4 is e to the negative pi over 4, which, but 5 pi over 4, over here, this is going to be negative. So this is going to be 0, some sort of positive number, and a negative number. So you don't actually need to figure it out necessarily. But again, what you're saying is the position here is going to be 0. My position here is some positive number. My position here is some negative number. So that's where it's going to be the most left. So what you can say is it's going to be, what is the question asking? Furthest left. So you're going to say t equals 5 pi over 4 because that is only critical point with negative position. So basically, remember, your critical points tell me where I have possible maxes and mins. So if this is the only one with a negative, that's my absolute minimum. Again, you could actually plug it in and figure it out. However, since you don't have a calculator and you want to save on time, at the end of the day, you're really not going to be able to evaluate e to the negative pi over 4 anyway. You would have just figured out, okay, this one's positive, this one's negative, but you can do it just like this. Okay, so again, with SVA, first thing that we're always going to set up is we're saying, okay, what am I looking for? In this case here, I was looking for an absolute minimum, so I just took the derivative, set it equal to 0, find your critical points, and then I just had to interpret. Farthest left, kind of like saying absolute minimum. Okay, next, let's do B. The value of the constant a, which satisfies, okay, so then now here, what we're going to do is we're going to take x double prime of t, set this all up. So we're going to say take x double prime of t, and then I'm going to use my x prime of t as reference. So this is going to be e to the t, e to the negative t, sine t. So I'm just using chain rule or product rule again. And then plus negative e to the negative t cosine t plus e to the negative t cosine t plus negative e to the negative t sine t. So again, we're just using product rule on the e and sine, e and cosine. And then from here, positive e, negative e, so then these cancel out, and negative negative, so this is x double prime of t is equal to negative 2 e to the negative t cosine of t. Okay, so that's x double prime of t. So now what we're going to do is we're going to say a times by this negative 2 e to the negative t cosine t plus, what was this? Negative e to the negative t sine t plus e to the negative t cosine t. Oops, let me move this. Plus x, so what was my x? Plus e to the negative t sine t is equal to 0. So I want to figure out where this is equal to 0. Hopefully something cancels. So e to the negative t sine t cancels out with this. This can pair up with this. Yeah, so what we're going to have here is I'm going to factor out this e to the t. So I'm going to have negative 2a plus 1 times by e to the negative t cosine of t equals 0. So basically I factored this out. So using zero product property, this is equal to 0 or this is equal to 0. So negative 2a plus 1 equals 0, which means that 1 equals 2a. We divide by 2, so that means a equals 1/2. Again, really, really not too bad. It's just an algebra problem, but it's an absolutely disgusting algebra problem. This one over here is a trig problem, but again, same general idea. On the left, we're doing local max min, and we're mixing in the fact that we're dealing with trig problems. And on the right side over here, it's really not too bad. We're just doing derivatives of trig, setting it up, and then saying if it's equal to 0, and just trying to get a little tricky with our solving here. But again, whenever you're solving for certain things, if you can't just solve it normally, one of the best things to try is zero product property. So like try to find things that you can factor out, and then that's a good way to kind of set this up here. Again, mentally though, this is still an SVA. We're saying my position, if I derive that, I get velocity. If I want to find max mins, I take the derivative, set it equal to 0, find my critical points, interpret. I know that we're having a little trouble on this. So if you're having questions, let me know. All right, that's it. 4 down, 2 to go.